Hello everyone, especially to Dr. Pedrina Eliran. Um, Today I'm going to discuss about mean from group data. So before that, I would like to introduce myself. I'm Rolly De La Rosa Jr. I'm taking up Bachelor of Secondary Education, major in Biology. Okay, so my topic is all about mean from group data. But before that, I would like to have at least a quick review regarding this chapter. So we have the chapter 5, which is the measures of central tendency. Now, so in this chapter, we have two concepts in describing the performance of a group. So we have the measures of central tendency, and the second one is measures of variability. But in the chapter 5, let's focus for the measures of central tendency. So this concept is very important and helpful for us to understand the performance of a group. So if we say measures of central tendency, it is used to determine the average of the performance of the group. So in getting the measures of central tendency, we have three ways to compute or to get the measures of central tendency, which is first we have the mean, we have the median, and the mode. But let's focus on the mean. So that was the mean. Okay, so let's focus now on my topic, which is the mean from the group data. If we say mean from the group data, it is a data that is grouped together in different categories, or it is the process of finding the average of a set of data that are grouped together in different categories. We have two ways to get the mean from group data, which first we have the method, which is the midpoint method. The second one is the mean class deviation method. Okay, so in the board I have some examples. So it was taken on the book. So the first example, table 5.5, it is a computation of the arithmetic mean using the midpoint method. So, for example, we have the class limit arranged from highest to lowest number. So we have 96 to 100, 91 to 95, 86 to 90, 81 to 85, 76 to 80, 71 to 75, 66 to 70, 61 to 65, 56 to 60, 51 to 55, 46 to 50. So this is our class limit, which is arranged from highest to lowest number. Okay, so we have the second column, we have the frequency. So how do we get the frequency? Frequency, meaning to say, it represents the number of students having the grade from 96 to 100 class limit. So that's why we get the number 3. So frequency, it represents the number of students, how many students get the score or average within the class limit of 96 to 100. For example, we have 3 students from 96 to 100, so that's why we have the frequency 3. 91 to 95, we have 5. 86 to 90, we have 4, and so on and so forth. So again, frequency, it represents the number of students who got the score or average within the class limit. So this is our second column. Next, in our third column is our midpoint. Okay, so how do we get the midpoint? So for example, in getting the midpoint from 96 to 100, so we simply just add 96 plus 100 divided by 2. So this is how we get the midpoint. 96 plus 100 is equal to 196. Divided by 2, we get the midpoint of 98. That's why we have 98 here. Next, for example, how do we get 93? Okay. From our class limit, we just simply add 91 plus 95 divided by 2 for us to get our midpoint in this class limit from 91 to 95. So 91 plus 95 is equals to 91, 95, 6, 18, 196. 196. Divided by 2, we have 93. So, if you continue adding this class limit from 86 to 90, 81 to 85, and so on and so forth, divided by 2, then we will come up with this number. So, in the class limit 96 to 100, we have the midpoint of 98, 93, 88, 83, 78, and so on and so forth. So that's how we get the midpoint. We just simply add limit, which is the lower boundary plus the highest boundary of class limit divided by 2. So that is our midpoint. Okay? Next, let's proceed to the next column, which is the sum of frequency times the midpoint. So in this method, we always remember that we get the product of frequency and the midpoint. So that's why we use this first method. It's all about getting the product of frequency and midpoint. Okay, so to get the product of the frequency and midpoint, we just simply multiply the frequency and the midpoint. For example, 3 plus 98, we have 94. 5 times 93, we have 465. 4 times 88, we have 352. 5 times 83, we have 415, and so on and so forth. So, to get the total of the product of the frequency times the midpoint, we just simply add the total of frequency times midpoint, 294 plus 465, 352, 415, 468, 657, 408, 252, 174, 159, and 96. So that we have a total of 3,750. So this is the summation of frequency and midpoint. And the number of cases, we have 50. Okay, now we have the given. So let's proceed for the computation on how to get the product of frequency and midpoint using arithmetic mean. Okay, so we have the formula of arithmetic mean is equal to summation of the product frequency times midpoint divided by number of cases. So we have the given, we have the 3,740, which is our summation of the product of frequency times midpoint, and the number of cases, we have 50. So 3,740 divided by 50, we have the arithmetic mean of 74.8. So this is the product of frequency, and this is the mean, arithmetic mean of the product of frequency and midpoint using the midpoint method. Okay, so remember our formula. So x with dash on the upper portion, it expressed as arithmetic mean, whereas EFM, it is the summation of the product of frequency times the midpoint. And N stand for number of cases. Okay, so now to sum it up, in our example in computation of the arithmetic mean using the midpoint of method, we always remember that this method we are looking for or getting the product of frequency and the midpoint. This is our goal in using this method. And don't forget the formula. We have the arithmetic mean is equal to the summation of the product of frequency times the midpoint divided by the number of cases. Okay, so that is our example number 1 using the first method, which is the mean midpoint method. Okay. So next example using the second method, which is the computation of the mean using the class deviation method. So class deviation method, this is a method that gives a shorter way in computing the mean in a form of frequency distribution. So earlier in the midpoint method, we are looking for the product of frequency and the midpoint. Now in mean class deviation method, we are computing the mean in a form of frequency distribution. Okay. Mean class deviation method, it deals with the deviation observed values instead of raw scores from arbitrary origin in any of the class limits. So in this table, using the method of class deviation method, we have the formula of arithmetic mean is equal to midpoint of origin plus class interval times the summation of the product of frequency times the deviation divided by number of cases. Okay, so same number, so same class limit from our first example in midpoint method. We have the available class limit, which is arranged from highest to lowest number. So we have 96 to 100, 91 to 95, 86 to 90, 81 to 85, 76 to 80, and so on and so forth. So as I've said earlier, to get the midpoint, we just simply add the lowest number of boundaries of class limits plus the highest boundary of number of the class limit. For example, in the first row, which is 96 to 100, again, so we just, to get the midpoint of origin, we just simply add 96 plus 100 is 196 divided by 2. So we have 98. So that's why we have 98 here. So if you continue, add the lowest number, the lowest score boundaries of the class limit plus the highest score boundaries of class limit is 95, you can get the 93 and so on and so forth. So that's how we get the midpoint. Next column is our frequency. Again, as what I said earlier, the frequency stands for the number of students having a grade which is within the class limit of, for example, 96 to 100. So it represents the number of students having the grade within the class limits. So we have 3, 5, 4, 5, 6, 9, 6, 4, 3, 3, 2. So we have a total number of cases, 50. Okay. In our deviation, our step 1 to get this number is we need to choose any of the temporary arbitrary origin from any of the class limits. It's either from the top, from the bottom, or from the center. Okay, so in this case, in this example, so we choose our arbitrary origin at the center of the class limit. Okay, so what is the center of the class limit? To get the center of the class limit, you just simply add 96, this row, 96 and plus 46 is equals to 142 divided by 2 is 71. So meaning to say, our arbitrary origin that we're going to choose from the center of the class limit is 71 to 75. In our deviation, we always start from 0. So we just put 0 here. So this is our center of the class limits, which is 71 to 75. So in the deviation, it should be start by number 0. So if the class limit is arranged from highest to lowest, above 0 deviation is positive. So we have 1, 2, 3, 4, 5. So it's positive. And if the arrangement is from lowest to highest, above 0 is negative. So in this case, our class limit is arranged from highest to lowest number. So if we start with 0, above 0 is positive and below 0 is negative. So this is our deviation. Next column is our the sum of the frequency times the deviation. So earlier we have the frequency. So again, it represents the number of students having the score within the class limits of 96, 200, and so on and so forth. So that's why we get this frequency. So to get the sum, we just simply multiply the frequency times deviation. 3 times 5, we have 15. 5 times 4, we have 20. 4 times 3, we have 12. 5 times 2 is 10. 6 times 1 is 6. 9 times 0 is 0. 6 times negative 1 is negative 6. 4 times negative 2 is negative 8. 3 times negative 3 is negative 9. 3 times negative 4 is negative 12. And 2 times negative 5 is negative 10. Okay. Now let's have the addition and subtraction to get the sum of the product of frequency times deviation. So first, we add 15 plus 20 plus 12 plus 10 plus 6, we have positive 63. Next, 6, negative 6 plus negative 8 plus negative 9 plus negative 12 plus negative 10, we have negative 45. Positive 63 and positive negative 45 rather will give us the total of 18. Okay, so that's why we have 18 here. Now, let's continue our computation of the mean using the class division method. So we have the given already. So we have the midpoint of origin. So to get the midpoint of origin, we just simply add 98 plus 48 is equal to 146 divided by 2 is 73. That's why we have 73 here, our midpoint. So midpoint of origin is 73. So the class interval. How do we get the class interval? To get the class interval, we need to find the range first. So we just simply add the highest score, subtract rather, highest score minus the lowest score, so we get the absolute range. For example, we have the range of 98, the highest score, minus the lowest score is 48. We have the range of, we have a total of 50. Okay. 50 divided by 10, we have 5. So this is our class interval. So as you can see, in our class limit, we have a class interval of 5. So remember, how do we get the class interval? Just simply add, subtract rather, the highest number score minus the lowest score divided the total divided by 10. So that's give us the class interval of 5. Okay. Now the summation of product of frequency times deviation is 18. Then we have the number of cases, we have 50. So this is our given. Now using our formula, so the arithmetic mean is equal to midpoint of origin plus class interval times the summation of product of frequency times deviation divided by number of cases. So midpoint of origin, we have 73. We have the class interval of 5 times 18 divided by 50, number of cases. So just simplify, just copy the 73. 5 times 18, we have 90. Copy the divided by number of cases, 50. Again, let's have simplify. 73 plus 90 divided by 50 is 1.8. Will give us the arithmetic mean of 74.8. So as you can see, the mean value obtained using the two methods are the same. We have the arithmetic mean of 74.8, and this method also we have 74.8. To understand it well, so we have another example using the two method in getting the mean from a group data. Okay, so in our example, it is the test result of Tupi National High School students. So we have 50 students, 10 per row. So this is their grade or score, their test result. from their test. Okay. So in computation of the arithmetic mean using the midpoint method, we always remember that it is done by getting the product of midpoint and frequency. Now, for us to understand it well, we need to start first or establish first the class limit for us to know later how we come up for that different numbers. Okay, so remember, in the midpoint, it is done by getting the product of midpoint and frequency. Okay, for example, in this computation, first we need to establish the class limit. So how do we come up with or establish the class limit? Simply, we just first find the absolute range. So to do that, we just simply look for the highest score and subtract it by the lowest score of the test result of Tupi National High School students. For example, in this test result for 50 students, we have the highest score of 98. And the lowest score we have the 48 here. So we just simply subtract the highest score and the lowest score to get this number, 50. Okay. The next step we're going to do for us to establish the class limit, we just divide 50 by 10 or by 20 for us to get the class interval. So from this result, 98 minus 48, we have 50. Divided by 10, we have the class interval of 5. Next step. Okay. So we just simply get the half of the class interval. For example, 5 divided by 2 is 2.5. Now, to get the class limit, the highest score we have, 98, plus the 2.5, we have 100.5. Again, 98 minus 2.5 is 95.5. Okay, to substitute or to convert it into the integral limit or to have it a whole number, we just simply add 0.5 from the lowest score, which is 95. So 95.5 plus 0.5 is equals to 96. So we have 96. Next, 100.5 minus 0.5, we have 100. Now, we already established our class limit, which is 96.5 with the class interval of 5. Okay, so let's put 96 to 100. Okay, so next, 100 minus 5 is 95. Okay? 96 minus 5 is 91. 95 minus 5 is 90. 91 minus 5 is 86. 86 minus 5 is 81. 90 minus 5 is 85. 85 minus 5 is 80. 81 minus 5 is 76. 80 minus 5 is 75. 26 minus 5 is 71. 75 minus 5 is 70. 71 minus 5 is 66. 70 minus 5 is 65. 66 minus 5 is 61. 65 minus 5 is 60. 61 minus 5 is 56. Then, until we come up with the lowest number, which is 48. 60 minus 5 is 55. 56 minus 5 is 50. 50. 55 minus 5 is 51 rather. 55 minus 5 is 50, and 51 minus 5 is 46. Okay. So we already established our class limit, and we know already how to come up or how to solve or to get the class limit. So first, we need to get the absolute range, the class interval, and next this step, set up the classes, this one, then so that we can get our class limit here. Next, so again, our midpoint method, it is done by getting the product of frequency, midpoint and frequency. Okay, so now let's get our midpoint. What is our midpoint? Establish our midpoint. Okay, to get the midpoint of our class limit 96 to 100, we just simply add the lowest number of class limit boundary plus the highest number of class limit boundary is 100 divided by 2. Okay, so 96 plus 100 is equals to 196 divided by 2 is equals to 98. So that's why we have the midpoint of class limit 96 to 100 is 98. Next, 91 plus 95 divided by 2. 91 plus 95, 186 divided by 2 is equals to 93. Next class limit, 86 plus 90 divided by 2, 176 divided by 2 is equals to 88. Okay. So if you continue doing like this, just add this, the lowest boundary of number of class limit plus the highest number of boundary of the class limit divided by 2, you can have the midpoint. You can establish your midpoint. Okay. So after we continue getting the midpoint, we established already our midpoint 98, 93, 88, 83, 78, 73, 48, 68 rather, 63, 58, 53, and 48. And now let's proceed to the frequency. So how do we establish the frequency? So as what I've said earlier, frequency, it represents the number of students getting the score within the class limit, or for example 96 to 100, if how many students get the score or test result within this class limit. For example, here in the test result of Tupig National High School. So we need to look for the frequency within the class limit of 96 to 100. Okay, so the first column, 96 to 100, we don't have. First column. Second column rather, we don't have. Third column. The fourth column, we don't have. And our fifth column, we have 98. So the frequency within the class limit of 96 to 100 is 1. So let's put number 1 here. Okay. Next example. For our class limit 91 to 95. So our frequency, so remember frequency, it represents the number of students getting the score within the class limit of, for example, 91 to 95. Okay. Based on the test result of Tupig National High, student of Tupig National High School, first column, 91 to 95, we have 92. 1. Fourth column. Fifth column, we have 95, 2, and 94, 3. So that's why we have 3 here. As we proceed, checking the test result of Tupig National High School, so we establish our frequency. So remember, frequency represents the number of students having the score within the class limits. So if you continue using our steps, you can have this one. Next, we need to establish the product of frequency and midpoint. So frequency times the midpoint. Okay. So we just simply multiply 98 times 1 equals 2, 98. 93 times 3 is 279. 88 times 2, 176. 83 times 6 is equals to 498. 78 times 4 is equals to 312. 73 times 12 is 876. 48 times 9, 68 rather, times 9 equals to 612. 63 times 5 is equals to 315. 58 times 2 is 116. 53 times 3 is 159. 48 times 3 is 144. So to get the total of, or the summation of the product of frequency times midpoint, we just simply add this number from top to bottom. 98 plus 279 plus 176 plus 498 and so on and so forth. We have 3,585. Now, using our formula in the method of midpoint, in getting the mean from group data using this method, midpoint method. Okay, our formula is expressed in arithmetic mean is equals to the summation of the product of frequency times the midpoint divided by number of cases. So we have the summation of the product of frequency times midpoint. We have 3,585 divided by number of cases, 1 plus 3 plus 2 plus 6 plus 4 plus 12 plus 9 plus 5 plus 2 plus 3 plus 3 is 50. So we have 50 here. So 3,585 divided by 50, we have 71.7. This is our arithmetic mean using the midpoint method in getting the mean of group data, in getting the mean from group data, which is 71.7. So again, let's have another example using our second method, which is the mean class division method. So now let's proceed to our second example, which is which is the mean class deviation method. Okay, so in class deviation method, this method gives a shorter way in computing the mean in a form of frequency distribution. So earlier, we already established our class limit, our midpoint and frequency. Now let's proceed to the deviation. Let's establish our deviation using this method. To establish our deviation, first we need to choose any of the temporary arbitrary origin from any of the class limits. It's either from the top or the bottom or in the center. Okay, so in this case, I choose our deviation, our arbitrary origin will be on the center. So what is the center or the center of our class limit? Okay. Again, to locate this one, we just find, let's look for the center of the class limit. We have 96 to 100, 91 to 95, 86 to 90, 81 to 85, 76 to 80, 71 to 75, 66 to 70, 61 to 65, 56 to 60, 51 to 55, 46 to 50. Okay, to get the center, we just simply add 96 plus 46 is equals to 146 divided by 2, we have 71. Okay, this is the center. Next, again, 100 plus 50 is equals to 150 divided by 2, we have 75. So now, we already have our center, 71 to 75. Okay. So, arbitrarily, our deviation starts with 0. So, we already locate where is the center of the class limit. So, our deviation starts with 0. Okay. So, if the class limit are ranged from highest to lowest, above 0 is positive. 1, 2, 3, 4, 5. Then below 0 is negative. Negative 1, negative 2, negative 3, negative 4, negative 5. But if the class limit is arranged from lowest to highest, above 0 division is negative and below 0 is positive. Okay, we already established our division. Next, we need to get the summation of the frequency times division. We need to establish the sum of frequency and division. So we just simply multiply. 1 times 5 is 5. 2 times 4 is 12. 2 times 3 is 6. 6 times 2 is 12. 4 times 1 is 4. 12 times 0 is 0. 9 times negative 1 is negative 9. 5 times negative 2 is negative 10. 2 times negative 3 is negative 6. 3 times negative 4 is negative 12. 3 times negative 5 is negative 15. Okay. To get the summation of the product of the frequency and the division, we just simply add this number. 5 plus 12 plus 6 plus 12 plus 4 is equal to positive 13, 9. 9 plus 10 plus 6 plus 12 plus negative 15 will give us negative 52. Okay. Positive 39 and negative 52 will give us the answer of negative 13. So this is the summation of the product of frequency times the division. Okay. Now, in using our method, using the formula, which is arithmetic mean is equal to midpoint of origin plus the class interval times the summation of the product of frequency times the division divided by number of cases. So, midpoint of origin, so we need to look for the midpoint of our origin. So to get the midpoint, we just add the highest score and the lowest score, which is 98 plus 48 divided by 2 will give us the answer of 73. So our midpoint here is 73 plus our class interval, we have 5. As you remember earlier, we have 5 class interval here. So, just copy number 5 times the summation of the product of frequency times deviation, which is negative 13 divided by 50. 73, let's simplify, let's copy the 73, plus, 5 times negative 13 is negative 65 divided by 50. Again, let's simplify. Let's copy the 73. Then copy the sign, which is negative. 65 divided by 50 is 1.5. 3. Next, 73 minus 1.3 is 71.7. So this is our arithmetic mean using the formula of the class division method. So as you can see, or as you remember, the result using the two methods give us the same arithmetic mean, which is 71.7. So remember, always remember our formula in midpoint method, which is arithmetic mean is equal to summation of the product of the frequency, midpoint times frequency, and our formula in using the class division method is arithmetic mean is equal to midpoint of origin plus the class interval and times the summation of frequency, the summation of frequency, product of frequency times division. Okay, so that is our formula in using the two different methods. So again, thank you very much and have a good day.